In this next section, we're shifting focus to the NIST Cybersecurity Framework in its current version 2.0. I'll give you a high-level overview of how it's structured and how it complements SAMM. The NIST CSF is a program-level framework to help manage and reduce cybersecurity risks. Let's briefly recap again the difference between cybersecurity and application security. Cybersecurity has a broader context. It includes protecting networks, infrastructure, data, users, systems, and many more topics, while application security is sort of a subset of that, focused on securing the software that you build and run, or sometimes acquire and run under the shared responsibility model. CSF covers the cybersecurity scope. However, it seems to largely omit the application security topics. It does have a section on secure software development and in fact refers to another NIST standard, but it doesn't go deeper than that. So in that sense, CSF is highly complementary to SAMM, where SAMM could be just plugged in for application security. CSF is developed by NIST, which is a highly reputable organization. But unlike SAMM, it's not open source, though it's still free to use. Just like SAMM, CSF is versatile, agnostic to organization type, tech stack, size, and it is widely adopted. Here is a key difference with SAMM. CSF is descriptive. That means it outlines outcomes, statements that describe what good looks like, but it doesn't tell you exactly how to get there. That said, NIST does provide implementation examples as sort of guidance. Another difference is measurability. While CSF can be measured, it doesn't include quality criteria like in SAMM, which makes it a bit more flexible, but it also means comparing across organizations could be tricky since interpretation will vary. All right, let's take a look at the structure of NIST CSF version 2.0, because version 1, which was widely adopted and it's still widely adopted, has a sort of different structure. There are missing elements there. At the top in CSF 2.0, we have 6 functions. These are the core pillars for managing cybersecurity risk. Each function contains several categories, and unlike SAMM, CSF is not symmetric. So for instance, govern function has 6 categories, while identify has only 3. And at the most detailed level, we have something called subcategories. CSF also calls them outcomes. These describe specific actionable results. So the structure goes function, category, outcome, but don't expect perfect balance like in SAMM in terms of symmetry. Here is a quick overview of each of 6 functions. We start with govern. This is about the organization's overall risk management strategy. It defines and communicates expectations, policies, standards. It also covers roles and responsibilities, and a big emerging area, supply chain risk management. Identify is about understanding your risks, knowing your assets, and setting targets to close any gaps. All of these sounds extremely straightforward, yet I have rarely seen an organization that has a clear view of their risks, and don't even get me started on having a clear listing of their assets. So, if by now you got stressed, don't be. Protect is the most extensive function. It covers identity and access management, training, data protection, and platform security, which, by the way, is where SAMM would fit in. Protect also includes infrastructure resilience. Detect has a more limited scope. It's about monitoring and analyzing events to spot potential issues, ideally before they escalate. Respond is your incident response function. Think business continuity planning and coordinated response processes. And finally, recover is about bouncing back after an incident. For these last 2 functions, by the way, NIST Special Publication 834 is a great complementary standard to look at. Let's do a first comparison between CSF and SAMM. It's actually nice to see how much structural overlap there is between the two standards. In CSF, a function maps directly to a business function in SAMM. Each one breaks down into categories in CSF or security practices in SAMM, both focused on specific high-level topic. Then we have outcomes in CSF, which align closely with streams in SAMM. In both cases, these are risk mitigating measures. The real divergence happens at the lowest level, or the highest level of detail. SAMM provides much more structure here, 3 activities per stream, clearly tied to maturity levels and backed by quality criteria that define what good looks like. CSF, on the other hand, offers implementation examples. These are very helpful, but they are optional and not exhaustive. So the detail and consistency you get with SAMM just isn't there. CSF introduces the concept of tiers, which are somewhat comparable to maturity levels. Tiers reflect the rigor with which each outcome is implemented, and they tie directly back to your organization's risk management approach. So the higher the tier, the more structured and consistent your implementation is meant to be. While tiers weren't originally designed for measurement, you can absolutely use them for that purpose. So you could, for instance, use 0, 1, 2, and 3 as a scoring for tiers 1, 2, 3, and 4 respectively to assess how well you're performing a given outcome. Despite using different terminology, CSF tiers and SAMM maturity levels actually align pretty well. Here is how I would map them. SAMM level 0, which is explicitly defined in the model, doesn't really have a direct equivalent in CSF. But that's mostly a technicality. You could easily define a tier 0 in your scoring approach. In fact, the SAMMY tool does exactly that. CSF tiers 1 and 2 would roughly align with SAMM maturity level 1, basic ad hoc practices in place. CSF tier 3 would map to SAMM level 2, where things become more efficient, repeatable, and structured. And finally, CSF tier 4 aligns with SAMM level 3, a state of maturity where practices are optimized and deeply integrated. So while the language differs, the progression and intent are very similar. Let's look at a concrete CSF example. Here is an outcome that says your users, services, and hardware are authenticated. First thing to note, CSF doesn't say you must do this. Just like SAMM, it's risk-based. It's up to you to determine whether this outcome is relevant for your context. Also, CSF doesn't provide quality criteria. There is no strict definition of done. Instead, it offers implementation examples, which are very helpful, I gotta be honest but they are neither mandatory nor exhaustive. That's both the strength and the weakness of CSF. It is very flexible, which many organizations would appreciate, especially compared to SAMM, which might feel somewhat rigid. But this also means measurability is very subjective. You could implement MFA and claim you've met the outcome, even if it's not sufficient given your threat landscape or context. That said, CSF goes a step further. NIST provides an official mapping to NIST 853 special publication, which is a detailed control framework. These controls are concrete risk mitigating actions. So if you use CSF together with 853, you get both the big picture strategy and the implementation depth. CSF has also a concept they call profiles, and it's a really interesting one. It's actually very similar to what target postures are in SAMM. As I've mentioned earlier, how well you implement each CSF outcome should depend on your risk. But let's be honest, I've rarely seen teams that actually know what their risk is with a rigorous analysis. Even if they can intuitively understand it, they rarely practice a structured and methodological approach. That's why NIST came up with profiles, which are essentially predefined targets for specific risk scenarios or specific threats. Think about anti-ransomware profile, DDoS resilience profile, and so on. And honestly, these are great ideas. The SAMM team is exploring similar concepts, profiles for a tech startup, financial institution, healthcare application, Cyber Resilience Act readiness profile, and so on. Now, that said, CSF hasn't produced that many profiles yet, at least in its version 2.0. I think only 1 or 2 are officially published, but once you understand the framework, you can and you should start defining your own profiles tailored to your organization's context. All right, time for another quick comparison, this time between CSF profiles and what we have in SAMM. Just a heads up, some of the terminology I'll use here isn't really part of the official SAMM language, but the capabilities absolutely exist. Whether you call them postures, profiles, or something else doesn't really change what they do. So in CSF, current profile maps closely to a SAMM assessment. Where are you today? Target profile in CSF is like a target posture in SAMM, where you want to be based on your risk. And the community profile concept in CSF is kind of what we call a roadmap posture in SAMM, something informed by others in similar contexts, helping you build your improvement plan. Once again, even though SAMM and CSF look structurally similar, they really do serve different purposes. And honestly, you should be using both. SAMM is focused on application security, and in my opinion, and I'm pretty biased, doesn't really have a true alternative. But what about CSF? Well, CSF does have some alternatives. The first one is CyFun, Cybersecurity Fundamentals, a Belgium framework that's actually inspired by CSF. As opposed to CSF, CyFun does come with profiles that are validated against concrete set of threat scenarios. So I would say that CyFun is actually a refined and somewhat improved version of CSF. Unfortunately, CyFun is currently only available for CSF version 1.1. Then there is ISO 27001. Like I mentioned in the introduction, ISO has a broader scope as it is an information security framework, and it is also internationally recognized. However, keep in mind that ISO 27001 is compliance-based. It's more about checking the boxes and building a tailored risk-based program. Now, just because ISO 27001 is typically used for compliance doesn't mean you can't flip the script. Nothing stops you from implementing ISO 27001 as a security-first framework and then perhaps getting the compliance certification as a bonus. Instead of going through the controls with simple yes and no answers, you could evaluate them using something like the Capability Maturity Model Integration, or CMMI. That way you get measurable maturity, not just checkboxes. Let me quickly explain what you're looking at here, CMMI, or Capability Maturity Model Integration. It's a maturity model originally built for software engineering. But these days it's used all over the place, including overall security. And the model defines 5 levels of maturity. On the far left, you've got chaos, randomness, inconsistency, everybody doing their own thing. On the far right, optimized, you've got a well-oiled machine that learns, improves, and adapts over time. What I like about CMMI is that it helps you go beyond yes or no. You're not just asking, do we have a process? You're asking, how good is it? So if you're looking to use ISO 27001 as a security-first framework, this model gives you a way to measure progress and not just ticking the boxes. And the bonus will be you get a compliance badge.